Welcome to the Crazy Hat Chemist. So another video here on acid, bases, and titration. So let's get moving. Bam! So today we're talking about acid-base calculation number 3. Here's the question. What is the hydroxide ion concentration, the hydronium ion concentration, the pOH, and the pH of a 0.024 molar calcium hydroxide solution? So the first thing that we need to do is get the formula for calcium hydroxide. Calcium is a group 2, that's a +2 on an ion charge, and then hydroxide is a polyatomic ion, that's a 1- charge. I'm going to take the 2 and the 1, I'm going to flip, I'm going to bring it down, I'm going to get the formula for calcium hydroxide, that is CaOH in parentheses with a 2 subscript outside. This is aqueous. Okay, and then we need to know something about calcium hydroxide. Calcium hydroxide is a group 2 hydroxide. Since it's a group 2 hydroxide, that means that calcium hydroxide is a strong base. Therefore, I can write the following equation based on that information. So I got calcium hydroxide, that is CaOH parentheses and a 2, that's aqueous. I got a unidirectional arrow because it's a strong base and it dissociates or ionizes 100% to produce on the product side 1 calcium ion, that's a Ca2 plus aqueous, and 2 hydroxide ions, that's 2 OH1 aqueous. Okay, so I have a 0.024 molar calcium hydroxide solution, so that's what goes right there. Okay, then I need to dissociate this, and I'm using the mole ratio. That is 1 mole of calcium hydroxide to 1 mole of calcium ion. Okay, knowing that this is a strong base and it dissociates 100%, ionizes 100%. So that gives me the calcium ion concentration of 0.024 molar. Now, this question most certainly did not ask for the calcium ion concentration, and that's not part of it. But you should be able to get that value regardless, just like we did with the nitric acid on the previous problem. We got the nitrate ion concentration, which was the same as the nitric acid concentration, because it's in a 1-to-1 mole ratio, just like the calcium hydroxide and calcium ion concentrations are in a 1-to-1 mole ratio. So I'm going to point out this 2 stoichiometric coefficient, and that is going to be an important number here, because the mole ratio between calcium hydroxide and the hydroxide on the product side is a 1-to-2 mole ratio respectively. Therefore, to get the hydroxide ion concentration, I'm going to take the calcium ion concentration and I'm going to multiply it by 2, or the calcium hydroxide ion concentration and multiply it by 2. So that's why I get 0.048 molar for the hydroxide ion concentration. So what is the hydroxide ion concentration? It is right there. I just solved for it. And I know this because this is a strong base and it dissociates 100%, but I'm using the stoichiometry to come up with this value. Now, from this value, I'm going to derive all the other components of which I am asked for in this problem. So I'm going to use the Kw right here. That is the hydronium ion concentration times the hydroxide ion concentration is equal to the value of the Kw, which is 1.0 times 10 to the negative 14 at 25 degrees Celsius. All of these are assumed to be at 25 degrees Celsius. I'm going to plug in the hydroxide ion concentration into this equation right here like thus. Then I'm going to divide both sides by the hydroxide ion concentration of which I was given, and I'm going to get the hydronium ion concentration. That is right here. So now I've solved for the second thing. And that is the hydronium ion concentration is 2.1 times 10 to the negative 13 molar. That is moles per liter. Okay? Now from this, I still need to get the pOH and the pH. Now, I have a variety of different ways of manipulating all those equations that you have memorized. Okay, so it doesn't matter which route you take. You could take the hydroxide, take the negative log of that and get the pOH, take the hydronium ion concentration, take the negative log of that and get the pOH. Or you can try another alternate method. So I'm going to take the hydroxide ion concentration, I'm going to take the negative log of that. So negative log of 0.048 is going to give me the pOH. And here is the pOH value. The pOH is 1.32. Okay? All right, so now I've got hydronium ion, I've I've got hydroxide ion concentration, I've got hydronium ion concentration, and now the pOH. So now I need to get the pH of this solution here. Okay, so I'm going to take the pH plus the pOH is equal to 14. That's one of those equations that you've memorized. I've plugged in the pOH value into this here. Now I'm going to subtract 1.32 from both sides, and I'm going to get the pH value. The pH value is 12.68. I got 2 decimals in both the pOH and the pH. That's important. The other component here that I want you to understand conceptually is, does this number for the pH make sense? Well, calcium hydroxide is a group 2 hydroxide, which is a strong base, and therefore it should be very basic. Therefore, the value for the pH should be well beyond, and that is above 7 and closer to the 14. Why? Because it is a strong base. Now, it is a very dilute solution, so therefore it's not going to be 14. That's why it's 12.68. Does that number 12.68 make sense? Oh, most certainly it does. Okay, so you've got all the parts in solving for that problem there. I am the Crazy Hat Chemist. I hope you enjoyed that video. Here's a crazy hat. Looks like I got a giraffe here today. Give me a thumbs up with that video. Subscribe to my YouTube channel. And I'm going to see you next time for more cool chemistry videos. I'll see you next time. Bye for now.